Awesome. Now I'm seeing more. Okay, so I'm going to go ahead and start now since I see a lot more people popping their answers up there. Again, let's talk about frequency. We talked about this yesterday. It is the number of overall cycles in 1 second. And before we measure frequency, we got to measure a cycle per second. And obviously we know our units as in hertz with a capital H lowercase z. So what is the frequency? When we look here, we have to go ahead and ask ourselves, we're counting the wave cycles, okay? So a wave cycle is one bump and one downwards bump. That would be one wave cycle. Another bump and a downwards bump would be another wave cycle. Looking here, I have one wave cycle. I have two. So yes, I do agree with all of you up on board that yes, it is going to be 2 hertz is going to be my frequency. All right, so let's go ahead and look at what song are you thinking about doing for your project. A lot of good songs out there. Again, let me throw this out there. If you are unsure about your song or you're not quite too sure, please, please, please email us and we will let you know if it's a go or no. So email us, let us know if you're unsure about it. We would be happy to let you know and see how it goes. All right, so let's go ahead and look at this. You're going to rock and roll us. Never Going to Give Up by Rick Astley. Okay, excellent. Okay, and I will tell you right now, people, I am so old. I don't even know these songs. I need to get my head out of the sound of music and get into modern times here, but you know me. All right, so Canyon Moon by Harry Styles. Paris, excellent, by Caro Emerald. I don't know, some song, a good song. All right, excellent. It's literally old. You don't know, never do. Don't give up on me, people. Don't give up on me. I will catch up. I know what Avatar the Earthbender is. It took Mrs. Larkin a year for me to understand that, so don't give up on me. So, all right, excellent job, everybody. Again, if you have any questions, please email us. We'd be happy to help you out. Remember that this Class Connect session is recorded and distributed for learning purposes. Please do not put any personal information or information of others into the chat box for your protection and the protection of others. It was released in 1987, and I should know this. I really should know this stuff. I need to get it with the times here. Make sure that you're respectful to all and also always participate often and well here in class. Excellent. All right, so let's go ahead and look at our agenda. Our agenda is that we are in day 34 of our 60-day adventure. It is Wednesday, October 7th. Our topic today is going to be sound wave calculations. Part 1, there is 2 parts to it, but part 1 is today. We're going to be doing this through our slides 12 and 13 of our Unit 4 project. All right, let me go ahead and look at our Unit 4 as we zipping right through. Let's talk about what we're going to talk about today. Define and determine period from a graph of a wave. We're going to compare frequency and period. And finally, use frequency to calculate period and vice versa. We're going to do this all through slides 12 and 13. And so as we are moving along, we're going to have you go ahead, and I'm going to go ahead and throw up these links here because it is time to open up our it's time to open up our links, and I'm going to put them in the chat box here. Boom. There we go. My computer was stalling on me. All right, so Mrs. Larkin's going to throw those links up here, up on the board here. If you've started this and you need to go onto this first link here and you need to find your Unit 4 project. When you find your Unit 4 project, you're going to go ahead and then click on the master copy and copy slide 13 and 14. If you have not started your project yet, then you're going to go ahead and click here and to say make a copy. If you want to, if you're having issues or if you need to get a Google account, here is a link for that. Now, I suggest that you wait to do this until the end or until you're done with classes. Take pictures on so on and so forth, but to let you know, your school account is not a Google account. It will not allow you to open up. So with that being said, if you need a Google account, it's amazing that you've gotten this far so far. But if you do need to make one, go ahead and click here. Do that later. So for today, just take pictures and screenshots, and then you can go ahead and create your Google account. If you prefer to wait until the very end of the project and then upload all the slides, then have your camera or your screenshot ready so that you can get all the information that you need. So at the end, you could then just plug it in and you'll be away you go. So with that being said, I'm going to go ahead and just check on one thing. Excellent. I need to go into my drive, and I am going to pull up so many here. Mine have all been copied, so I cannot show you. Anyway. All right, so I'm just going to show you one of my copies. Unfortunately, because I'm teaching multiple classes, they are not showing up, so I will show you how to copy them. So with that being said, we're going to go ahead. Here is my original template, okay? Now, understandably, we teach multiple classes, so I've already done this, and it just hasn't shown up. It already shows up on my original. But what you need to do is, I've found this in my drive. I'm going to go ahead and then get my copy, my master copy, so I just go ahead and load in my master copy. What I can do then is go down to slide 12 and 13. We're looking for slide 12 and 13. Make sure you highlight it. You can go shift and highlight again. That makes you highlight two of the slides at the same time. Once you've done that, you're going to go ahead and push copy. Then you're going to go to your original, and you're going to go ahead and push right click it, and it's going to say paste. Go ahead and paste it into your original copy. If you're having issues, let us know. Again, give us a green check when you have completed that. Go from the master, highlight it, right click, copy, and then go to your original. Go to the very last slide, which should be slide 11 right here. Go ahead and right click it. It will say paste right here, and go ahead and just paste it in. All right, and then it should pop in. There's also an alternative where you could do Control C when you're on the master copy, and then Control V when you go into your original copy. That could work also. Now it will pop up saying that it do you want it to link? You can say no, do not link. It does not matter. All right, so go ahead and give us a green check when you have that. If you're having issues, let us know. If you're having issues, let us know. Green checks. Excellent. So you have not started it? If you haven't started it, that's fine. Then you would be going down to this one right here. But if you have started it, it's probably in your Google Drive. So you're going to need to click on this first link, and then you need to look for it. If you are waiting to the very end to complete it, then just wait. Just take pictures, screenshots, whatever you need to do, okay? That's okay, Isaiah A. That's okay. I should put a little Back to the Future song in there. Maybe that song Back in Time. That's a pretty good one. All right, let's go ahead. I'm going to check in with a few people just to make sure that we are A-OK. Adrian. Green check, red X. Red X will let us know if we are having issues. Let's see, Annabelle, green check. I'm going to go ahead and shut my camera off because I feel like there is a huge delay. All right, looking for Angelo, green check. Bowen, green check. Bryant, green check. Darius, green check. Looking for Isaiah A. Ivana, green check. John Paul. John Paul, do you like to be called JP or just John Paul? Let us know. Green check. Jose, green check, please. Kalia, green check. Kion, green check. Thank you. I saw it. Kalia, thank you so much. Luis, green check, please. Matthew, good, green check. Excellent. Let's get. Isaiah, it's okay if you're gonna wait though. The green check just simply says that you're with us, that you understand, and that maybe you're taking pictures or that you're taking screenshots. Okay, that just lets us know that you are with us. It doesn't mean that if you're waiting till the very end to do this, that's a-okay. But it just kind of gives us an idea that you are with us, you're participating, you're here with us. All right. All right, let's go ahead and let's get some more green checks. Again, there is 30 of us in class. Excellent. Beautiful. All right, let's go ahead and move on.
All right, everybody. So projects, remember, are graded on a 0 and 5 through 10 scale. This is going to be due in about a week and a half. We haven't settled on a final due date just because we want to figure out how many days of additional work days we need to give you. But it'll probably be due in about a week and a half. So you do have some time, Jadlyn. All right, so projects, remember, are graded on a 0 and 5 through 10 scale. This means that as long as you try on every single slide, you will get a 50% or higher. So this means it's to your advantage to just do your best best on the projects. Basically, everybody who does the project and it's pretty clear that they watch the video instructions gets an A, B, or C. So it's very easy to do well on the projects. You just need to start them, and you need to try your best, and you need to watch the video instructions. The only way you get a 0 on a slide is if it's extremely clear that you did not watch the video instructions, or if you leave it blank. So don't leave things blank, and make sure you do them while you're watching the video instructions. Again, you don't have to be perfect. This scale is to your advantage. A 5 means you're not quite there yet. A 6 means that you are getting there. 7 means that you're proficient. 8 means that you are really on top of it. 9 means you're almost at mastery, and 10 means that you have mastered it. So that's why we grade it on a 5 through 10 scale and not a 0 through 10 scale, because we're not grading it on how much you get correct, we're grading it on what level of understanding that you have. So your strategy should always be to try to get 2 questions per slide correct, because that'll make sure that you get a really good grade on the project. Obviously aim for higher, but if you're stressing about one particular project and you feel like that one problem and that one problem is going to make you give up, then just skip it for now. You can go back and try it again later. Just try your best, okay? So focus on getting at least 1-2 questions per slide right, and then go back and do the harder questions as you get through them, okay? Remember, projects are 70% of your grade. It's impossible to pass if you don't do them correctly. So make sure you're doing them correctly. It is, Isaiah. All right. So I do have an example of here of what your slide number 4 should eventually look like. Again, you do have a week and a half before this project is due, so that gives you plenty of time to begin working on your art. Tomorrow you will have some time to work on your projects. So tomorrow, I highly recommend, if you've already completed your other slides, slides 7 through 13, then you should begin working on your artwork tomorrow if you haven't already. All right, so this right here is a painting that I did of my nephew and my niece last year for Christmas. And so again, Daniel, we don't have an exact due date just because we are waiting to see how much help students need to figure out how many additional work days we might need. So for now, it should be due around next Friday the 16th. Okay. All right, so we can see here that I have the starting sketch that I did, and then in the middle I kind of have when I did some of the colors, and then at the end I have the final product. Now you don't have to have colors until the end, right? You might have a starting sketch, a middle sketch, and then add colors to the end. Yours does not have to be painted. You can just use colored pencils, markers, crayons, whatever coloring things you have at home. If for some reason you have no coloring things at home, let us know. We can always send you some coloring things or come up with an alternative for you as well. Artwork does need to be done by hand for plagiarism reasons. We don't want you screenshotting somebody else's work because there are a lot of tutorials on how to do virtual work, so we're not doing this virtually. We're doing it by hand. It can be as simple as you want, all right? It does not need to be as complex as what I did up here. If you want to do abstract shapes and then just color in those shapes, that's totally fine. If you have medical restrictions, please make sure you let us know. We do have alternatives solutions. We can work with you to make alternative solutions. Again, it does need to have 5 colors. It does need to be done by hand. Please make sure that you write your name on it before you take each picture. You can see I have my names up here. I didn't put my name on the middle one, so oops, Mrs. Larkin. Need to make sure I put my name on the middle one. But make sure that your name is on there. That way we know that it's actually your work and you're not taking pictures of somebody else's work. Thanks. Again, you need a start, middle, and final photo. In the chat box, please give me a birthday cake if you feel comfortable with this. Of course, you can have more than 5 colors. You just need at least 5. So no less than 5. You can have 5, 6, 7, 8, 9, 10 colors. You cannot have 1, 2, 3, 4. You need to have more, 5 or more. Awesome, Bowen. Did you get a starting, middle, and ending picture? Hopefully we did. Looking good. All right, everyone. So let's go ahead and do a brainstorm today. I want to know, what does it mean to do something periodically? For example, my daughter got this shirt when she was younger that says, I nap periodically, when she was a baby, because boy, did she nap periodically. And she's the daughter of 2 chemistry teachers. So people like to give us chemistry stuff. So tell me in the chat box, what does it mean to do something periodically? Awesome job, Bowen. You are so on top of it. I love it. Yeah, Natalie, email us and we can go ahead and send you some. We have a little budget as teachers, so we can just send you some. Okay? So yeah, if you don't have coloring supplies, let us know and we can make sure to send you something simple to make sure you can color your stuff. All right? So email us right now. All right, awesome. I see Bowen in the chat box. All right, so this is something that happens over time. What other ideas do we have? when we think of periodically? What does it mean that my daughter, when she was younger, napped periodically? Awesome. I see Stephen in the chat box. Right. It might mean frequently. What else? Think about the context of what I'm talking about. Think about when you might have heard the word periodically in the past. Go ahead, tell me what other synonyms or what other definitions can you possibly think of? No, Natalie, it's totally fine. You can use paint, you can use markers, pencils, crayons. So yeah, if you want to get your own stuff, that's totally fine. If you need help getting stuff, again, just let us know. We're happy to help. Yeah, so it can mean from time to time, time to time. It can mean occasionally, occasionally. Yeah, if you've never heard it in the past, that's totally fine. Just think about the context. What does it mean that my daughter napped periodically? So based on that sentence, based on what you know about babies, what does it mean that she napped periodically? Thank you. Yes, Luis, I got your sign up. Thank you so much. All right, it means she's a heavy sleeper. Yeah, so what I'm saying here is when we think of periodically, we think of this idea of something that repeats. So it happens more than once, more than once. So that's good to think about. Now, another way that the word period can be used is in periodicals. So periodicals, for example, are newspapers and magazines that are published at regular intervals. All right, regular intervals. I'm going to go ahead and, oops, why do I keep on spelling regular wrong? Regular intervals, which means that they're published every week or every day or every year, right? So we have this idea that they're happening regularly. So not only are they repeating, but they're happening regularly. Go ahead in the chat box, give me a star so far if that makes sense. Star so far if that makes sense. I know Zoom would be really nice. It's just Zoom, you don't have as much control over like stopping a student's video if need be. So that's why we haven't quite moved over to something like Zoom yet. Yeah, all right. The last one I want you to think about is what do you think of when I say time period in history? What do you think of when I say time period in history? All right, sorry, I was just typing. Yeah, so we should think of like the future, right? We could think of the future. What else can we think of? So the future, we might think of Jurassic time period, which is in the past, right? We might think of, I don't think there's a siren going off. A section of time, I love that, right? A section of time. Right? How long might a time period be? Go ahead and tell me in the chat box. How long might a time period be? Oh yeah, I took a typing class when I was in like first grade. So I learned how to type really fast, really young. Yeah, so it could be a very long time, a very long time, right? So that could mean it could be like hundreds of years, hundreds of years. It could be decades, right? Think about the 30s time period or the 40s or the 50s. Those are all a decade long. All right. So what I'm seeing here is that time periods have some sort of measurement, right? There's some sort of measurement of time. Awesome. So these three things are going to be related to today's lesson. Before we jump into this, how we use the word period in physics, though, we're going to go ahead and have to review something from yesterday because it's related to what we're doing today. A decade is 10 years. So yesterday we talked about frequency, and frequency is the number of overall cycles in 1 second. So a whole second, all the cycles that happen in a whole second. So all the cycles that happen in a whole second. Sorry for my spelling mistakes. Remember that we measure this in cycles per second or in hertz. I like to say that frequency hertz just because that's an easy way to remember it. So I want to figure out what is the frequency down here. Remember, we need to count up the total number of waves. Remember, one wave is both a top and a bottom bump. You will need to be able to do this a little bit later, so make sure you're paying attention. Tell me in the chat box, what is the frequency here? We can see a top and a bottom bump. What is the frequency here? Count up the total number of waves. If you need to use your pointer on the board to help you count, that's totally fine. So count up how many total waves do you see? Up, downs, how many total up, downs do you see here? A single wave cycle is a top and bottom bump. All right, it's a top and bottom bump because after that it starts to repeat. So you go from a top to a bottom and then again, it repeats again. Good, I see Lisa, I see Bowen, I see Antoine. Bowen, I think you might have miscounted slightly, so go ahead and try one more time. And don't forget your units. Remember, frequency hertz. Go ahead and measure frequency in hertz. Thank you, Rowan. Thank you, Andres. Love seeing those corrections. Thank you, Brisa, Jaylyn. Looking good, Andres. Yeah, so I see lots of people in the chat box. You are correct. You should have 8 cycles here. So you can see 1, here's 2, 3, 4, 5, 6, 7, and 8. Right? I can label those 2, 3, 4, 5, 6, 7, and 8. So 8 total cycles in 1 second means that this has a frequency of 8 hertz. Great job, everybody. Okay, now period, on the other hand, is going to be a period of time for only one wave. So previously we tried to find all the waves in 1 second. This time we're going to figure out what's the time for just one single wave cycle. All right, so we want to think of this as a period of time, which we're going to be measuring in seconds. Now remember, a single wave cycle is again a top bump and a bottom bump, because after that it then begins to repeat. So go ahead, point for me on the board. All right, if this is where I'm starting the wave, where would this first wave end? Go ahead and point for me on the board. Where do we have a top and a bottom bump? Where does this first wave end? Go ahead and point for me on the board. Excellent. I see people working up there, looking good. I see Stephen and Antoine, Lisa on the board. I see Sally and Caitlin participating. Let's make sure we're getting lots of participation up there. I see Jaylyn working up there. Perfect. Get your answers on the board. Where do we see that first wave ending? First wave ending. Thank you, Andres. I see you up there. Get your participation up there. Looking good. All right, I would totally agree. Take a look at where everyone is pointing. Let me pause those tools just so I can label it. You are correct. The first wave ends right here, right? There's a top bump and a bottom bump, and then we go back to a top bump, which would be repeating, so we don't want to include the next top bump. So this right here is a single wave, a single wave. Now take a look at the graph and read the graph. How long did it take for that single wave to occur? Take a look at our graph in seconds. How long did it take for that single wave to occur? I see Lisa working in the chat box. I see Antoine typing. Awesome. I see Jade Lynn working. I see Sally and Daniel in the chat box. I see those units. We love units. What is the period here? How long did it take for that single wave? Read right underneath on the graph. Beautiful, you are all doing amazing. Yes, this is 0.6 seconds. We have a period of 0.6 seconds. Great job. All right, again, this is one that you'll need to be able to do on your own on your project in just a moment. So make sure you are practicing with us. It's to your advantage to practice with us. That way you can do the final one on your own. All right, let's go ahead and do another practice.
All right, so let's look at this practice. Remember that a period is the time it takes for a single wave cycle to be completed, and we measure that in seconds. So looking at that, again, we know what a wave cycle is: one bump and one valley, I guess you could say. Or you could say one hill, one valley. Either way, it doesn't matter, but you need a top bump and a bottom bump to make a wave cycle. So with that being said, we're going to go ahead and measure this wave cycle. So looking at for that top bump, bottom bump, where would I point it? I'm going to give you your whiteboard tools. Where would be my wave cycle? Point to where my first wave cycle would be. Point to where my first wave cycle would be. Remember, a wave cycle needs to be a top bump and a bottom bump. Perfect. Where is the end of that first wave cycle? Excellent. Beautiful job. Good. You need a top bump and a bottom bump. Beautiful. I'm going to go ahead and put those whiteboard tools on hold. Beautiful job, everybody. I think you got that. So with that being said, I'm going to go ahead and let me just and I'm going to keep that smiley face right there because that is going to be the small. So now we're going to go ahead and look at the time. We're going to find that time right here on this particular line. And what time do I see? What is my period? Good. Excellent. Excellent. Beautiful. Yes, it's right there, and it says it is going to be 0.2, and I am, there we go, 0.2 seconds. Oops, got 0.2 seconds. Excellent. There you go. Excellent. And this is how long it takes for that single wavelength, and if you look at it and you actually look at this, you would notice that it then repeats itself at 0.2. If I looked at my next wave cycle, it would be at 0.4, my next wave cycle at 0.6, so on and so forth. So it repeats, okay, repeats. Excellent job, everybody. So let's go ahead and look at doing this on our own. I think we feel comfortable enough. Here we go.
All right, so we're going to go ahead and go to slide number 12 of your project. Again, at this point, you should have already copied it. If you hadn't had a chance to copy it, go ahead and just take a picture and you can copy it up there later, just because we don't want to spend too much time waiting for us to fiddle around with copying, okay? If you need help copying, make sure you text or email us or tell us in the private chat and we'll go ahead and help you out. We'll probably send you a link to tutoring. That way we can help you one-on-one. All right, so period is the time it takes for a single wave cycle to be completed. So you need to find where is the first wave ending. Where's the first wave ending? Remember, a wave is a top and a bottom bump, and then it starts to repeat. And then go ahead and measure the period using the graph. Let me go ahead and share with you what this looks like up on the board. Oh, sorry, I shared the wrong. Okay, so here we go. I'm going to go ahead and open this up. And we are taking a look at slide number 12. Okay, so what you want to do for slide number 12 is you'll see that I already put a dot at the start for you, at the start of the wave, all right? But what I need you to do is place a dot at the end of the first wave cycle. So at the end of the period for the first wave cycle. So again, a single wave is both a top and a bottom bump, and then it starts to repeat. So you only need the top and the bottom for the first wave cycle. So just click on that dot, click and hold, and then you should be able to drag it around. Again, just place it wherever you find the end of the first wave, okay? Then go ahead and take a look at the graph, read the graph, and actually type your answer. So take a look at the graph and type your answer. How many seconds did it take for that single wave? Okay, go ahead. If you need help checking your answers in the chat box, please go ahead and chat us. We have the private chat on. Otherwise, you have, let's see here, 45 seconds to work on this. Give us green checks. If we don't get your green check, we'll go ahead and check in with you in the check-in room. Green checks, go, go, go. Again, you can ask for help in the private chat. All right, a few more seconds. Green checks, please. Again, if you want to check your answer, we're in the private chat for you. All right, just waiting on Adrian. Green checks, please. Bowen, Bryant, Charity, Daniel. Green checks, please. Darius, Eric, Isaiah, Jadelyn, Jalen, John. Green checks, please. Keon, Kalia, Luis, Madison, Matthew, and Timothy. And we need your green checks. Otherwise, we'll go ahead and move you to the check-in room and then check in with you. And then don't forget, if you want to just take a picture and work on it later, that's fine, but take a picture. That way you know what you need to do. Okay, awesome. Timothy, Timothy, green checks. Madison, Madison, green checks. Keon, Keon, John, John, green checks. Eric and Adrian, just waiting on your green checks. Looking good. Thank you, Madison. Awesome. Just going to move a couple people that we haven't heard from and check in with them. We'll send them some private chats. Thank you. Looking good, everyone. All right, let me go ahead and jump us back over. Awesome job, everybody. All right, so here we go. Frequency and period we're going to see are going to be related, but not actually the same thing. So they are actually opposites. Frequency is the total number of cycles in 1 second, whereas period is the time for just one cycle. So cycles in 1 second versus seconds for one cycle. So they're actually opposites of each other. Let's go ahead and take a look at an example down here. Let's go ahead and first calculate the frequency, the total number of waves that we see here at the bottom. All right, so go ahead and count up how many total waves do you see all the way up to 1 second. All the way up to 1 second, how many waves do you see? Tell me in the chat. Excellent. I see Antoine, Lisa working. I see Jade Lynn. I see Sally, Brisa. I do see a surprising lack of units, though, for as much as we love units. Thank you. Correcting those mistakes. Great. Making sure we have the fully correct answer. Love it. Yes, you should see 5 total waves, right? So we see 5 total waves in 1 second. All right, in a whole second, right? So here's our first one, here's our second one, our third one, our fourth one, and our fifth one. Lovely. Now, period, on the other hand, is the time for just one cycle to be completed. So take a look, where is our one cycle and how long does that one cycle take? How long does that one cycle take? All right, seeing answers in the chat box? Yes. So that one, awesome. So that one wave is definitely almost only 0.2 seconds long, right? So this one wave right here takes 0.2 seconds. And so our period right here is 0.2 seconds. Now, what I want you to notice though is that each of these waves actually also takes 0.2 seconds. Remember, period, we said periods are repeatable. So this one's another 0.2 seconds, this one's another 0.2 seconds, here's another 0.2 seconds, and another 0.2 seconds. So here's what I want you to notice. When you add up all the little periods together, you end up with the total amount of time of 1 second. So these things are opposites of each other, right? Cycles in 1 second versus the seconds it takes for one cycle. Go ahead in the chat box, give me a lightning bolt if that's beginning to make sense. Lightning bolt if that's beginning to make sense. All right, beautiful. Here we go. All right, so we're going to see this represented in the calculation as well, in the equation. So the frequency of a wave is going to be the inverse or the opposite of the wave's period, which means that we take it and we flip it. All right, so if you have a number, you flip it, and by flipping it, you make a fraction where it's underneath the number 1. All right, so we're just flipping it. All right, so period is represented by a capital T, not a lowercase t. Lowercase t just means like time in general. A capital T means that it's a repeated time. So repeating period of time. Frequency is represented by an F, easy peasy. So the two equations that we have are that period equals 1 over F. Again, we're flipping it to make it the inverse or opposite. Or vice versa, frequency is 1 over period. Again, you can see it's being flipped and put underneath 1. We're flipping it, making it the inverse. Let's take a look at an example here. What is the period of a 440 hertz sound wave? All right, tell me in the chat box, hertz is the unit for what? Hertz is the unit for what? Tell me in the chat box. Excellent. I see Stephen, Lisa, Antoine. Looking good. Yes, hertz is going to be the unit for frequency. Frequency, hertz. All right, so taking a look here, we are solving for period, which means I'm going to go ahead and use the period equation. Period equals 1 over frequency. What should I plug in here for F? What should I plug in here for F? Excellent. Caitlin, Lisa, Antoine, I see you there. Awesome, yes. 440, so 1 over 440. Grab a calculator and tell me, what do you get? What is 1 over 440? Awesome, I see Lisa working, I see Eric working, Rowan working, Antoine working. Yep, 1 divided by 440. Remember, 1 over 440 is the same as saying 1 divided by 440. So 1 divided by 440. Start off with the 1 and then divide by 440. Make sure you, yeah, give me 5 decimal points. 5 decimal points. So 0.0022 and then that last number. Go ahead, get your answers in there. Oh no, Sally, I'm so sorry. PVC is just being so mean to you today. Awesome. I see Lisa in the chat box. I see Rowan in the chat box. What are we getting? 1 divided by 440 equals what? Work quickly, please. We don't want to run out of time. Awesome. Yes, you should be getting 0.00227. 0.00227 seconds. Awesome. The time for one wave cycle is 0.0047 seconds. What is its frequency? All right, so frequency is going to be 1 over period. Let's go ahead and look here. What should I plug in for the period? All right, period is the time for one wave cycle, so what should I plug in for the period here? Excellent. Yeah, we're going to plug in this period of time, right? The time for one wave cycle, that is literally what period is. And so right down here, we put in 0.0047, and what is 1 divided by 0.0047? What is 1 divided by 0.0047? Lisa, I see Caitlin typing, Sally typing, Antoine typing. Make sure you're participating. We're going into passing period a little bit because we're being a little bit slow to participate, so make sure you're participating as fast as you can. Awesome. Yes, you should be getting 212.7 hertz. Great job, everybody. All right, so what you need to do is we're going to go ahead and apply this to your slide number 13. Now we're almost out of time, so we didn't get to do our second practice, so I'm going to go ahead and work a little bit on annotating this one with you, and then you should be able to plug it in and calculate it. So the average female's voice has a frequency of 205 hertz, which makes it sound higher pitched. What is the period of this sound wave? So right here, 205 hertz has been identified as the frequency, and we're solving for period, which is why we use the period equation. So period equals 1 over frequency, plug in that frequency, do the math, and get your answer here. Now over here, a typical wave in the ocean is caused by a wind that has a period of 20 seconds. What is its frequency? Again, this 20 seconds right here has been identified as the period, and we're solving for frequency, so that's why we use the frequency equation. Frequency equals 1 over period, plug in the period, and then solve for your answer. I'm going to go ahead and share with you really quickly what slide number 13 looks like. Again, you should have copied slide number 13 from the master template, Daniel. I'll go ahead and send you the link to the master template one more time. Here you go. All right, let me share this with everybody up on the whiteboard. For slide number 13, again, if you need to take a picture, that's totally fine. At this point, though, you should be able to do this one on your own. So the average female's voice has a frequency of 205 hertz. We said that was frequency. What is the period? Taking a look here, here's the equation. Period equals 1 divided by frequency, which equals 1 divided by, fill in the frequency. Go ahead and solve that, and that should be your period. You already have units here, so just keep the seconds here for your units. Go ahead and solve for the period. Then down here, a typical wave in the ocean is caused by wind that has a period of 20 seconds. What is its frequency? Frequency equals 1 divided by period, which equals 1 divided by, fill in the period, solve that, and that should give you your frequency in hertz. Go ahead, take a picture of this and give me a green check, or solve the answers and give us a green check. You have 60 seconds. Then we will go ahead and do your attendance. Apologies, we're going a little bit into passing period. We're going to turn off the chat if you would like to check your answers with us. Go, go, go. You have 1 minute. Oh, can you not see my screen? Let me know if you can't see the screen for some reason. Waiting on green checks. Angelo, Antoine, Bowen, Bryant, Jalen, Jorge, Jose, Kalia, Luis, Matthew, Sally, Stephen, Timothy. Green checks. Awesome. Yeah, Jadelyn, that's correct. Caitlin, you can round if you want to. I think it does actually round up. We'll still give you full credit though. Just make sure you have 5 decimals for the first decimal places for the first answer, and then the second answer just have the regular answer. Looking good. Awesome, Lisa. Awesome, Eric. I see your answers. Looking good. Let us know if you need help on the first one or the second one. Let us know if you need help. Again, we're in the private chat to make sure that you are on track. Green checks Matthew. Green checks Timothy. Sally, I see you're typing. Green checks Jalen B. Awesome. Great job, Sally. Okay, yeah, Stephen, if your slides are off, just make sure that you get whichever slide you're missing. And then obviously the titles will help you. So we're on the frequency and period equations slide. Awesome. Great job, Eric. Looking good. All right, everybody, let's go ahead. I'm going to jump back over here and give you your attendance. All right, so for your attendance, Sally, you're really close. Go ahead and put that into the calculator again, though. I think you might have written the number wrong. For your attendance today, we're going to go ahead and send those links to you in the chat box. Oops, sorry. Where are my links? Where are my links? Here we go. Here's your links. All right, go ahead and I'm going to turn your chat back on, everybody, for you. Here you go. You're going to tell me what was the period that you determined from the graph on slide 12. All right, so just take a look at slide 12. You should have already gotten an answer. That is what you need to put into your attendance prompt. Click Start a New Thread, and then tell me what was the period that you determined from the graph on slide 12 of your Unit 4 project. You will get full credit as long as you're close, though we might respond and let you know that you're a little bit off. All right, thank you so much, everyone. We'll give you 1 minute to do that, and then we will start logging people out. See you all later. Great job, everybody, today. Great participation. We'll see you later.